Okay, first I apologize about any background noise, but and in this lesson you're going to learn to use intercepts to graph a line. We've already learned the y-intercept, right? That's the place on the y-axis where the line crosses, okay? It's the y-coordinate of a point, um, and the the y would be wherever the line crosses this axis, okay? So the x-intercept then is going to be the x-coordinate uh, where the line crosses the x-axis, okay? We're going to essentially write the equation in standard form, okay? Standard form says ax plus by equals c, where a, b, and c are real numbers, and they're going to be not just real numbers, but we're going to have them be integer values, okay? So we're not going to have fractions or decimals here for these numbers, okay? Which means we'll just multiply everything until we get them to be whole numbers, and then we will juggle them around so the x's are here and the y's are here, and then the constant is on this side. Why does it matter? This form will allow us to do this. Watch what I'm going to do. This is a little preview of what we're going to do. The standard form makes it really easy to find the y-intercept, which is, let's say, down here at -4. We can have a point. And we can also use it to find the x-intercept, which may be, let's say, over here at 7. Okay? Remember, all it takes to graph a line is 2 points that we know are on the line. So once we have that, we can say, all right, now that I know that, let me just make a line that runs through both of those points, and I have graphed a line. So standard form makes it really easy to find the intercepts, and by finding the intercepts, you just connect them and you have the graph of the line. Okay, that's the idea behind this. So we're going to explore this in more detail, and it's actually pretty cool and really handy in the right situation. And one big idea that I should mention before we move on is that if let me say I write down the coordinates of this point, we have it as 0, comma, -4, because every point that's on the y-axis has an x-coordinate of 0. Remember that the coordinates just describe the movement that you make from here to the point. And if we wanted to go from here straight down to here, okay, then we don't move left or right. This x-coordinate tells us how far we move left or right, and we don't want to move left or right. We want to move 0 units left or right, so x is 0. Any point along here will have an x-coordinate of 0, right? And remember, in an equation, we can say we can find the other number if we can give us like one of them, everything but the one missing number, right? If you can give a value to it. So if we have two variables, x and y, we can say let's make x be 0, and we know we're looking for the point comma 0 for that point there, because the first number, the x-coordinate, tells you how far do I move left or right, okay? And how far do I move left or right? Well, I move 7 units to the right. That's why it's a positive number, moving to the right. Now, how far do I go up or down? Well, we don't want to go up or down from here. We simply want to go left or right. So this number is going to have a value that's not 0, because we do have to move some units from there, but we do not want to move up or down. Once we get over there, we want to move 0 units up or down. So every point on the x-axis will have a y-coordinate of 0, okay? Whatever axis you're looking for, the other coordinate is going to be 0. And why does that matter? Because then in the equation, we can plug in 0 for y, and it'll produce for us the proper x value to match where we are on this axis, okay? Big idea. So here we are, finding those intercepts. Once we find them, we'll eventually be able to graph them. Right now, we're just simply going to find them. What are the x and y intercepts of 3x plus 4y equals 24? This is in standard form. A, x plus b, y equals 24, where 3 is the a and 4 is the b value, the coefficients of x and y. Okay? So first of all, it says to find the x-intercept, we substitute 0 for y, because remember, to find where you are on the x-axis, the other coordinate, y, has to be 0, and we will then solve for x. Now, why do we substitute 0 for y? To find the x-intercept, remember, the x-intercept is the x-coordinate of the point on the y-axis, and any point on the x-axis has a y-coordinate of 0, as I just said. So what do? You then take the equation and you write the equation substituting 0 for y, and this whole term becomes 0. 4 times 0 is just 0. That goes away. And we are left with 3x equals 24. Or, solving for that, x equals 8. So on the x-axis, we put a point at 8. That's 1 point on our line. Okay? It's not one of the coordinates. It's the x-coordinate, and the y-coordinate is 0. What do we do for step 2? We find the y-intercept by substituting 0 for x. When we put 0 in for x, this becomes 0, and we just get the simplified equation for y equals 24. Solving for that, we get y equals 6. This is not a coordinate. We don't have a point at x comma 6. I'm sorry, 8 comma 6. That's not what that says. What this says is 8 comma 0 is 1 point, and 0 comma 6 is another point. Because remember, the other coordinate is always going to be 0. And there it is, x is 0. So we have a y-intercept at 6. And by the way, if we were to then graph that, just to make a little sketch here, we would say, okay, I want to go over to the x-axis and put a point there at 8, let's say there. And then I want to go to the y-axis and put a point at 6, let's say it's there. And then therefore our line would look like that. Okay? But we're not graphing this one, we're just solving for the values. So the question is, sorry about that. Here you go. What are the x and y intercepts of each one? Solve that right now. Okay, so I'm going to shortcut the math just a little bit, and I'm going to say that if we put in 0 for x, then this term would go away. 0 for x, 5 times 0 would go away, and we would be left with the simplified equation negative 6y equals 60. Don't lose the negative on that, okay? And then what do? We have to divide both sides by the coefficient, negative 6, and we would get y equals negative 10. So we have a y-intercept of negative 10, okay? Likewise, if we went back to the same equation and we said, what if we put in 0 for y? That would make this term go away, and we would just get the simplified equation of 5x equals 60. And when we divided both sides by 5, the coefficient of x, we would get x equals 12, okay? And so that's our answer, is that the y-intercept is negative 10 and the x-intercept is 12. Don't make the mistake that the point 12 comma negative 10 is a point that matters. It doesn't matter. That's not on our graph. What matters is this. If I was going to show you the graph of it, is that you would say, okay, now we have 2 points down here. The y-intercept will be down here at, let's say, negative 10, somewhere down there. The x-intercept will be somewhere over here at 12, and then we would connect them, okay? Let's go to the next one, and we're going to do the same thing, essentially taking each portion and setting it equal to what's on the other side. So if I put in 0 for x, that would go away, and we would get the simplified equation 8y equals 12. Sorry, my pen is dying. Okay, and then dividing both sides by 8 and simplifying that fraction, we would get y is equal to, and this fraction would simplify down to 3/2, otherwise known as 1.5, 1.5, okay? The other thing that we could do is say, okay, well, let's put in 0 for y. And if we put in 0 for y, like that, we would get the simplified equation 3x equals 12. And then doing the same thing, dividing by the coefficient to get it down to a single x, we would find out that x was equal to 4. And so our line would cross the y-axis at 1.5 and the x-axis at 4. So now what we're saying is, what is the graph of this? So we're going to find those intercepts, which we did in the last step, and then we're just going to plot them and then connect them. Okay, so what do we know? We know the equation of the line that's given right here, and it's actually given in the proper form. We need the coordinates of at least 2 points on the line to graph it. That's all you need to graph a line is 2 points, okay? So how are we gonna do it? We're going to find the X and Y intercepts and we're gonna plot them and then draw a line through them, okay? This says, what do the intercepts represent? The x-intercept is -2, which means that you go to the x-axis and you put a point at -2, comma 0. The y-intercept is 1, so we go on the y-axis up to 1. The coordinates of that point are 0, comma 1. Okay, so find the intercepts. This is actually 2 separate bits. You want to just visually see this as separate. Okay, the first thing that they do here is they say, take the equation, put 0 in for y, and we'll solve out that x is equal to -2. Then we do the same thing here. We say put in 0 for x, we'll find the y-intercept, and we get this simplified equation, and when we solve it, we get y equals 1. Okay. So what do we do then? Well, we simply plot those points. Okay, on the y-axis, we go to -2. I'm sorry, on the x-axis, we go to -2. Put a point there. On the y-axis, we go to 1, put a point there. Boom, connect them, we are done. We've graphed that line. Pretty neat. Okay, so what is the graph of 2x plus 5y equals 20? Try that right now. So here we are. We have taken the equation. We put in 0 for x to find the y-intercept at 4. And we take the equation again and put 0 in for y to find the x-intercept at 10. And then what do I need to do? I'm going to make this big here, just up top so that you can visually see it. We are going to take a point and put it on the y-axis at 4. And we're going to take the point and put the x-axis at 10. And there we have our 2 points. And then now all we need to do is connect them with our line tool. Okay. You need graph paper for this. So if you don't yet have graph paper, I've been telling you over and over recently to get it. Get some graph paper because you're going to need to be doing these graphs. Anyway, that's what that looks like. Okay, so in this section, what it's telling you is that you can take equations that are for vertical and horizontal lines, and you can actually write them in standard form where you just have 0 for the coefficient for the missing variable, okay? And if you do that, then you can see that the intercept is going to be what the coordinate is every point along that line. So for example, let me get this out of here, okay? What is the graph of each equation? So what they're doing here, as you'll see, and I don't necessarily think you need to do this, because I know that you know how to graph these, okay? But what you can do is say, well, if it says x equals 3, that's like 1x plus 0y equals 3. That's writing it in standard form, right? Where you just put the coefficient of x and you put the coefficient of y, which is 0 because there are no y's, okay? And then you can substitute in, and what you'll find is that you're never going to get a y-intercept because it doesn't cross the y-axis, okay? Every single value of y, no matter what you pick, is going to give you an x coordinate of 3. But essentially, you already know how to graph this. The way that I taught you to graph this is this. You simply go to the x-axis at 3, and you say, I'm going to put a line that crosses that axis at 3, and every point has that. So you can just do that, right? Here, you could write this as 0 x's plus 1y equals 3 and do the same thing. But you can also just say, I'm going to go to the y-axis at 3, and I'm going to put a line that crosses it at 3 and graph them like that. So you could do it like that as well, okay? What is the graph of each equation? Again, this is a method they're showing you, but I don't need you to do it in this particular way. The important thing is that you correctly graph these. So you do it how you know how to do it, and check your answer when you come back, okay? And by the way, you need graph paper for this. Okay, so how are we going to do this? Well, very simply, I'm going to say, okay, if this one is A, the first one, and it says x equals 4, that means at 4 on the x-axis, we're going to have our line crossing it, and it's going to cross it at a 90-degree angle, right? So that becomes our graph of x equals 4. For b, x equals -1. That means go over here to -1, and we're going to put a line that runs perpendicular to, crosses it like that, at -1 for x. Okay, that's an arrow. Now, y equals 0. We're going to go to the y-axis at 0 and say we're going to have a point there at 0, and we're going to cross the y-axis with a line that's perpendicular to it. And that means like that. Okay, so you can see actually the x-axis has an equation of y equals 0. Like that describes the line that goes along the x-axis. Okay, and finally, y equals 1. We know it's going to cross the y-axis there at 1, so we draw a line that crosses the y-axis at 1, and we've graphed our lines. That's how you do it. So what we're seeing here is an instruction that you can actually take any equation that's in another form, and we can rewrite it into standard form using only integers for coefficients and for the constant, okay? So we're going to transform this into standard form. Well, what's the first thing that we need to do here? Okay, to get started, you need to get rid of this fraction. You need to undo the fraction. What's happening? There's a divided by 7 on the bottom, so we can multiply each side by the denominator. If we multiply both sides, but everything by 7, this by 7, this by 7, this by 7, every term, on this term it will cancel out and we'll still get whole numbers here. What does it look like? Multiply everything by 7. We get that times 7 is 7y. That times 7 clears the 7 off the bottom, and we get the -3 as the coefficient of x. And 7 times 5 is 35. The last thing we need to do is we need to just get the x's on this side because it's ax plus by equals c. So this is added to both sides, 3x added to both sides, and we get 3x plus 7y equals 35. Okay, we get good at rewriting equations because you need to be good at it. Okay, rewrite this into standard form using integers. And here's a hint. We can clear this fraction out by multiplying by its reciprocal. And it'll clear it there, and we'd have to multiply everything over here by that reciprocal. Try that. Okay, so one thing you could do is distribute if you wanted to, but we can also just, what I'm going to do is say, I can take the original equation, and if I multiply both sides by the reciprocal of -1/3, which is -3, I can say, okay, then we're going to multiply by -3 to everything on this side, y minus 2 equals, and then I'm going to do the same thing over here, -3 to everything that's on this side. And what's on that side? -1/3, parentheses, x plus 6, close parentheses. Okay? Well, this has the effect of canceling this out exactly. And what we get on that side then is just what's left, x plus 6. Here on the right, on the left-hand side, we need to distribute. So we need to multiply that to that and that to that. -3 times y is -3y. And -3 times -2 is +6. Okay? Now, I'm going to subtract 6 from both sides to get the constants on the right-hand side. That's where we want them. And as you'll notice, they actually will go away. Sorry, that's supposed to be a 6. Not a great one. And we get -3y equals x. Now we say minus x from both sides, minus x from both sides, and we get -x minus 3y equals 0. Actually, I'm going to write it up top. Let's redo this. I'm going to write it over here. Sorry for this messiness. -3y equals x. And if I subtract x from both sides, we get -x minus 3y equals, we took away what was there, so we're left with 0. Now, fun fact, they typically, not always, but the best convention is to not leave a negative number here. So we're going to change the sign of everything by multiplying everything by -1. So we're going to say -1 times everything that's there equals -1 times 0. I know it's still going to be 0. And what we get as a final result is it changes the sign of everything. And we get as our final answer positive x plus 3y, positive 3y equals 0. And that is our final answer, where we kept the front number positive. Okay? So this is just summing the concept up. Okay, you can describe any line using one or more of these forms of linear equations: slope-intercept form, point-slope form, or standard form. Those are the three big forms of equations. Okay, any two equations for the same line are equivalent. So you could write it in this form, you could write it in one of these forms, you could write it in this form, and you will still be describing the exact same line. When you graph it, you'll still get the same thing. Okay, where here's some point on the line, 3, 4. Here is maybe for this line the y-intercept of 0, 6. Here's the x-intercept of 9, 0. And you can see it's got a slope of -2/3. These are all features of a graph independent of how we write the equation. So here is the lesson check for this lesson. I need to embed the answers. I think we almost have an answer to why we don't have access to the teacher edition, so I will get this reloaded for you with that information. But you can try these and ask me any questions if you don't know how to do them. You can also just try the homework. Certainly, I hope you did the got it problems. Okay? Ask me any questions if you've got them. Good luck.